This is the atomic model.
Democritus was one of the first major contributors to the atomic model with his contributions starting in 300 BC. Everyone who had heard of Democritus's idea ignored it because they didn't believe it to be true. His idea was not credited to him until a lot later in history. He didn't have a model or a name for it, but he did have a theory. His theory was that matter did get smaller and smaller, but at some point they have to reach a point where they were unable to split any longer. He named this the smallest piece of matter atmosis, meaning not to be cut in Greek.
John Dalton contributed his ideas starting in the year around 1800. Dalton had been conducting experiments when one day he came across that there are small particles in matter. Nothing really led him to discover this, but he was interested when he did find it. Dalton came up with the idea of the atomic theory of matter based on his experiments and observations. Dalton's theory was based on the atoms of different elements. He believed that they could be eminent by the differences in their weights. The theory basically expanded on the idea of the atom given by Democritus. He thought it out further than Democritus and explained that elements and compounds are all connected. Dalton never actually made the model, but he did have the theory, so he was credited for it later. Since Dalton's theory, it has since been nicknamed the solid sphere model. Dalton's theory was an improvement on Democritus's because it had more believable information and he actually had evidence to back his theory up, but Democritus didn't have any evidence. He had just a theory. Dalton also believed that atoms were indivisible. This, at the time, was an improvement to Democritus's theory. The main points of Dalton's theories are: all matter is made of atoms. Atoms are indivisible and indestructible. Number 2, all atoms of a given element are identical in mass and property. Number 3, compounds are formed by a combination of two or more different kinds of atoms. And number 4, a chemical reaction is a rearrangement of atoms. Number 5 is atoms can be neither created nor destroyed. This is all from promocure.com. J.J. Thomson's theory was based around the fact that he discovered electrons. He founded the model in 1897. When Thomson discovered electrons, it changed everything from the past two theories. He was led to his atomic theory because he founded electrons. He wanted to find out how the electrons worked. Thomson's theory said that an atom consists of a positive charge which has negative charges embedded in it. This makes the atom neutral because both of the charges equal out each other. This was given the name plum pudding model because he believed that the atom was filled with good positive charges, but it also had some negative charges in the positive charges. So basically, the pudding is positive and the plum is negative. His experiments was done by using a high vacuum cathode ray tube. Thomson thought of the deflection of the rays by thinking they were electronically charged plates. He used magnetics as evidence of items that he knew were much smaller than atoms. This experiment led him to the findings of electrons, which led him to his atomic theory and model. Thomson's theory and model was an improvement from Dalton's theory because Thomson thought that since electrons were so small, they could only fit inside an atom, which made sense to many. Also, since Thomson discovered the electron, Dalton's theory that atoms are indivisible had to be changed. Ernest Rutherford discovered the nucleus, which further led to his atomic theory in 1905. After his discovery of the nucleus, Rutherford came up with his theory, which said that electrons surround a nucleus. He believed that protons and neutrons were also in the nucleus of the atom. The rest of the atom that wasn't taken up by the nucleus and the surrounding electrons was basically empty space. The name of this model was known as the planetary model. This is because the nucleus is filled with the protons and the neutrons, and then electrons are spinning around the nucleus outside of it. This model ends up looking like Saturn, the planet, with its famous rings. Rutherford's theory was an improvement on Thomson's theory because Thomson's theory model didn't say how the atoms worked. The Rutherford model showed that the nucleus controlled the atom in some sort of way. The new model gave reason to the atom. Niels Bohr was next to contribute to the atomic theory. In 1913, he proposed that electrons have an orbit around the hydrogen nucleus, much like the planets around the sun. Bohr was a student under the watch of Rutherford, so he just simply built off the idea of Rutherford. His model was also named the planetary model for obvious reasons. He investigated into Rutherford's theory farther because he wanted to find out what kept the electrons from falling into the nucleus. He then suggested that the electrons have fixed energies in their orbits that kept them from falling. These orbits were called shells. Bohr's model was an improvement from Rutherford's model because it showed how the electrons were kept from falling into the nucleus. Lastly, Erwin Schrödinger was the last one to find an improvement to the atomic model. In 1926, Schrödinger used the quantum theory to write and solve an equation when described the energy and location of an electron in a hydrogen atom. According to WiseGeek.com, the quantum theory is a method of explaining the nature of matter and how it behaves on an atomic and subatomic level. Schrödinger took this theory and made it into a model. He believed that instead of the electrons being made into the shells and having energy levels, they were arranged in orbitals which were distributed within the electron cloud. The electron cloud is the area around the atomic nucleus where the electrons probably are. He estimated that there is a 90% chance of electrons being able to be found in the cloud. This model was an improvement from the last because he showed that there is only a certain possibility that electrons can be found around the nucleus. Credits by Megan Montgomery.